Before we start, I think I owe you a little bit of some introduction of who I'm actually am to be sitting here and talking for 2 hours about a Zabbix, more specifically about SNMP and SNMP traps in a Zabbix. So I guess for those like who know me, probably you saw me in YouTube in all sort of different videos about a Zabbix. That's how most of the community actually found out about me. Like 7 years ago, I started a YouTube channel designated for all sort of Zabbix tutorials. At this point, we have something around like 100 and I guess 55-ish videos about a Zabbix, and at the end of this presentation, I'm also going to share like the channel itself and the links to the playlists for the Zabbix tutorial. Long story short, also happens to be like where this knowledge comes from, not just from my own personal usage of Zabbix and monitoring. Happens to be that I also worked in a Zabbix company itself for basically 9 years, close to that. I did start as a support engineer, learned a lot about concept of monitoring, about a Zabbix, about Linux, about all sort of this different distributions, databases, scripting, monitoring types, and so on and so on. Eventually gathered enough knowledge and experience like to deliver some turnkey solutions to the customers all over the globe. Also did a lot of the trainings. Proudly can say that I delivered the trainings for many existing trainers that are out there right now, which is awesome. And so yeah, overall it was like amazing journey in the Zabbix in the monitoring sphere, and over those years I gathered quite a lot of experience and knowledge about all of these things, which kind of makes me comfortable enough to sit here in front of you and talk about interesting topics. I'm gonna move the poll results away just to not confuse anyone. And as you know already, like the topic today is SNMP and SNMP traps in the Zabbix 7.0, which is, in my opinion, like let me move to the next slide to at least have some movement here on the screen. In my opinion, it could be like one of the most, I don't want to say like complicated, but most needed topics that people usually seek questions about. Because what SNMP monitoring essentially means is simple network management protocol. That's what SNMP stands for. But in a simple word saying, we talk about SNMP every time when we're thinking about monitoring of some network devices. And happens to be that, like, again, over all those years of experience, going to all sort of different exhibitions and conferences about Zabbix, when people come by and they want to learn something about Zabbix, they always think that, hey, Zabbix it's the software which is like for the network monitoring. And you guys probably already know that the Zabbix can do like much more than just the network monitoring, but for many people, monitoring is all around the network stuff because you can have some sort of the um, company or business or some setup building, whatever, let's say, without AWS setup or without a Docker setup or without a Postgres database that you would want to monitor. But it's very rarely when you will have some sort of the setup without a single network device. And all of the network devices usually have a big impact on our environment, like we are getting internet access from those network devices, which means that any outage of our network device, which also means the outage of the internet, would directly impact output of our business. Potentially, we would lose some money. So that is always very important, and we worry a lot about it, which makes us wanting to like monitor all of that stuff. And so SNMP is Internet Standard Protocol for collecting and organizing information about managed devices on IP networks and for modifying that information to change device behavior. Modifying like that is supported with SNMP, that is possible, but in terms of the Zabbix, we usually talk about monitoring. And devices that typically support SNMP include cable modems, routers, network switches, servers, workstations, printers, and more. And those are like the ones that we usually think about. But for some, it might be surprising that you can actually monitor like Windows server computer. You can monitor a Linux machine through the SNMP, though it's not like the most popular way how to do that because there are much more easier and much more convenient monitoring types. As example, on a Linux, you can install just a Zabbix agent and most critical metrics are going to be accessible for you out of the box. So there's no reason to overcomplicate a setup with SNMP. When we talk about SNMP, um, we usually hear about we usually hear like three different namings. We have SNMP v1, SNMP v2c, and SNMP v3. And as you can tell, as you can imagine, like all of those three are basically three different SNMP versions, while SNMP v1 is the first one, which was released, published in 1988. That's quite a long time ago, right? I was born in 1989, so SNMPv1 was out there to monitor your routers and modems when I was not even born. SNMPv2, which is, I would say it's like the golden standard right now. And That's the typical what people use because it has like a good compromise of supporting all of the monitoring metrics. We're going to talk a little bit in the next slides, like what's the main differences between SNMP v1 and v2, and between SNMP v3, which is the most secure. But security and encryption always comes with some price of performance that you need to pay because encryption takes some time to deliver the data, right? And also complexity of the setup. Like if we talk about SNMP v2, then you just need a community string. For SNMP v3, usually for someone who has no experience of SNMP usage. And as I said, like it's not the most trivial topic in the monitoring and overall, it might be just too complicated to set up monitoring with SNMP v3 because even creating a users and setting up all the authentication is a little bit of a hustle. So naturally, people might think like, okay, SNMP v1 is old. That we know for sure. SNMP v2 is like most popular version of SNMP to monitor. SNMP v3 is secure. When there's going to be SNMP v4 and will it bring something new? And I've actually, like yesterday, preparing for this webinar, did some research about the exact question. Are there any plans for SNMP v4? And I really like the responses that I found that SNMP v3 is considered complete. It has everything. It has everything that people need to monitor network devices, servers over the network, over the internet, and collect all of the data. It has security, it has protection, it has all sort of different abilities to collect hundreds and thousands of the metrics. So there's just no need for SNMP v4. And ultimately, most of the softwares and most of the systems right now are pushing in front of the streaming telemetry data. And telemetry data is something that if you are researching some sort of the monitoring, you definitely heard about it. A lot of the monitoring tools are using telemetry as their like flagship feature for the marketing and advertising that hey, we do support a telemetry. And interesting to know that also like Zabbix goes in the same direction. And like well, we cannot tell for sure until it is really released, but at least everything including the roadmap evidences that in a Zabbix 8.0 we're gonna have telemetry monitoring support within a Zabbix, so that's gonna be a good thing. How SNMP actually works: SNMP agent checks UDP port 161. So, what do we know about UDP? Alternative is like TCP, and in the case of UDP, we can lose the data, and that's fine. We don't really care about it so much. That's how the standard works. And basically, there are two key principles and key ways how we could collect the data. When we talk about SNMP agent, that includes all three: SNMP v1, SNMP 2C, and SNMP v3 as well. That goes on a port UDP 161. And basically, in this case, like if we're talking about a Zabbix server, then we have Zabbix server, which makes requests over SNMP UDP port 161 to, let's say, some network device, requests the data, which could be, let's say, incoming traffic on Ethernet 1, or CPU load of the device, or some memory usage, or operational status of the port. Like there's really a lot of the metrics that we can collect. And device responds with the actual metric. In terms of like, how do I know what do I actually request and how do I request that? Like when we talk about a Zabbix agent monitoring, it's mostly straightforward. Like you don't need to have a deep understanding and a deep knowledge of the things. You install agent, as example, you open documentation, look for the supported items, and they're kind of self-explanatory, right? You just look through the table and you see like, oh, there is a key system dot CPU dot load. Do you need more information to understand what this metric is? Probably not. You understand that we're talking about a CPU. With SNMP, it's a bit more difficult, and I guess that's the main confusion. Why so often SNMP is so difficult for many people, because in SNMP, we do the monitoring based on OID, which is like this syntax of dot one, dot three, dot six. And sometimes this string is like 20, 30 different numbers with the dots in between them. And each of those numbers, each of those OIDs actually references some specific metric, some specific data type. Later, again, we're going to talk about how can we understand what they are, what's the structure, and how to work with all of that. But alternatively to SNMP agent checks, when our Zabbix server, SNMP poller as example, or the regular poller, connect to the network device and request the data, receives the response, there are also such things about like SNMP traps. And the difference is SNMP agent is monitoring all the time, like operational status up or down. We might be monitoring this specific port or all ports on our device. And even if status is okay, we are still collecting the data. We're just checking every 10 seconds, status okay, status okay, status okay, everything is fine. So SNMP trap work differently. They work on some specific event that happens on a device. So let's say on a device, we can configure that, hey, when operational status of this port goes to down, I want to send a trap. And only then. If it's up, I don't care. So I will receive something in my monitoring server in Zabbix only if something is going to go off. And a good thing for you guys that like in this webinar, we're going to talk about both of these, SNMP agents and also SNMP traps. And I think also important to mention like both of these configuration is done not only on a Zabbix server. You're also going to need some input from network devices. And for whole of this webinar, when we talk about SNMP, I'm going to focus more like on network devices, right? Routers, Cisco, Microtech, Ubiquiti, you name it, right? Because those are the most popular ones. Like Windows, Linux is also an option, but not so popular as the network devices. So you would need some configuration and preparation on the network device as well, which means that if you're started to work in some company as a Zabbix monitoring engineer and you get a task that hey, we're just onboarding our Zabbix in our office, in our business, and you need to set up monitoring of all our network stuff, you're gonna need access to that network stuff, or you're gonna need someone who has access because you will have to go to each of the devices, enable SNMP monitoring, choose the version. If you want to go with version 2, you will need to specify community name, which is going to be used for authentication. If you're going to use SNMP v3, you're going to need to create a users and also make sure that some other parameters as engine ID are set correctly. So when we know like how the communication actually happens, um, let me actually try to also, where do we have here? Okay. Okay, I'll try to find it later. I wanted to get a Q&A section, but never mind. Um, a bit more on SNMP versions, like the theory, the plain raw data. SNMP version 1 applies with RFC 1213, released in 1988. Plain text community string. So community string is used for authentication. That's just going to be like one word or something like that, just some sort of the string that we're going to use to authenticate end to end. That makes sure that our router authenticates with our Zabbix. They have community string which matches, and then we are allowed to do the monitoring. The biggest problem with SNMP v1 probably is that because it is so old, it supports only 32-bit counters. And if right now, like a 32-bit counter sounds like, what are you even talking about? What does it mean? Wait for the next slide. We're going to have the real example of what's the difference. The golden standard SNMP version 2C supplies with RFC 1441, released in 93. So a bit younger, right? Same plain text community string adds a support for 64-bit counters, which allows it to still successfully work with everything modern, like internet connections and most importantly, internet speeds that are more common to nowadays than they were in 1988. Introduces get bulk command, which is a more efficient way how to get like a lot of the data from the device at once. Because as I said, like we cover just small examples of operational status of the port or description of the port or incoming traffic. But imagine if we talk about like 20 port device, and on each port you have like around 12 different metrics, and multiply that with a 20 ports, plus additionally you might have hundreds of different metrics like some VPN statuses, BGP, and all sort of that stuff. So we're actually talking about quite a lot of metrics that can even reach thousands. And collecting all that data one by one, even despite like being possible in theory, is often not efficient. So we need to deal with all sort of things that allows us to gather the data in bulk. And then SNMP version 3, RFC 2570, released in 1999, adds authentication, adds encryption, improved error reporting and reliability, and adds multiple SNMP contexts. So SNMP v3 is basically designated to have a better security. So for those companies, businesses, environments, and different use cases when you really care about security and privacy and making sure that nothing bad can happen in between of your monitoring setup and the device that you are monitoring, you probably want to choose SNMP v3. Although, as I said, it's going to be a little bit more complicated journey to set everything up, and it's also going to be a little bit easier to make some mistakes that can potentially cause you spending some time, hours, or even days to troubleshoot and understand what happened in case if you don't know all the specifics and things that you need to keep in mind when you are working with SNMP, which is exactly what we're going to try to cover here today. And going in a bit more details, like 32-bit versus 64 bits. So SNMP v1 versus v2 and v3. The shift from one to other in SNMP is primarily about preventing counter rollovers, or also sometimes called as counter overflow, on high-speed interfaces. And here is example: the traffic volume. 10 gigs is roughly 1.25 gigabytes per second. 32-bit limit is this crazy number of the bytes, which is approximately 4.3 gigabytes. Rollover time at this speed of the internet, which is like nothing big right now for current time, it's like nothing big. 32-bit counter will hit its limit and reset every 3.4 seconds, which means that like if we would be monitoring um this link with a Zabbix with 32-bit counters, we would just get some sort of the graphic, which let's say gives us incoming speed, outgoing speed, or something like that. And every 3.4 seconds, we would have some sort of the drop down. That would be the time when the counter actually overflows. And to fix that, the solution is like 64-bit counter. It's also different in terms of OID that you monitor. So the actual identifier of the metric. I previously mentioned that we have like dot one, dot three, dot six, and so on and so on and so on. Um, I think it's time for me to actually bring up the terminal and show something real. Give me a second. Uh, yeah, so what I was saying. We have this OID, which let's say, um, yeah, this would be the numerical way, right? The OID that I was talking about, 136 124 114, where people will usually look at it and not understand what it actually means. But if you have a MIB files, which are like a libraries of these identifier, and next to them having a bunch of information of like what this number actually means, then we see this as this with the actual textual information and index in the end, which allows us to more easily perceive. So the point that I'm trying to make is that here I have as examples listed 32-bit counter if in octets, which is the translated OID name. You can monitor if in octets. And you have a 64-bit counter if HC in octets, right? So each of these could also be used as some sort of numerical OID, 136 121 140, whatever it would match for this one. So basically, no matter if you see the textual representation or the numbers, we're basically talking about same stuff. This one, if we have MIB files, this one if we don't. And what are actual differences between both cases? Again, we're going to cover actually next slide. Management information base, MIB, which is a management information base, a database used for managing the entities in the communication network. That's exactly like a library to help you understand what everything is and what each number means. Because every time when you get are you going to explain how to create a template from a MIB file? Not directly, but I'm gonna talk in a way that you will understand how that actually works. So every time we are receiving SNMP data, like a bunch of different OIDs, it's very difficult to understand what exactly we need to monitor because we might be talking about hundreds or even thousands different OIDs. So without any knowledge and without the MIBs, we might end up just having to use Google. Let's say if we have some Cisco whatever device, you might Google just Cisco SNMP OID for the CPU load. But the problem is that very often you will find something it's hard to verify. Like you can check that value through the SNMP get or through the Zabbix, and you will receive some value, but there's no guarantee that what you're getting is actually what you want to get. Like you might be looking for CPU load, but the real metric that you're receiving might be something else. That's why the MIBs are very much helping us to determine what is going on. And here is RFC definition and some examples. So I previously mentioned this 1361, right? And basically, each of these OIDs is like a path to the actual metric. Here we have everything written just in one table. So one means org, three means org, six means DOD, internet is again one, then we have directory, management, MIB2, transmission, experimental, private, enterprises, and so on. And each of these numbers gets us somewhere into the tree so that in the end we can get to the box where we have our information. As example, if we would be looking for something about the interfaces, the good old interface status, operational status that I talked about, we need to provide this long OID to actually get to the data, which would for us be like our OID that we're monitoring can start with a 0, but it doesn't bring us anywhere. 2 also doesn't bring us anywhere. So for us, it's going to be 1.3.6.1 .2.1 and .2. That is going to bring us into the interfaces, and further down, like it doesn't stop here, it just stops here on the slide, but actually it goes much more deeper, and under those interfaces we would have even more data about all sort of different stuff, where we could also find the incoming traffic, outgoing traffic, operational status, and all of the other stuff. And here how it looks like from just different perceptions. So 1361 to management, MIB, system, private, Cisco, enterprise, HP, and so on, with the explanation of like what each OID index, each box actually gives us, like system related information, as example, device description or uptime. Interfaces, as I mentioned, interface related information, example, network interfaces on the device. Some MIBs and OIDs are vendor specific. As example, here you can see Cisco specific MIB, Cisco devices, private MIB objects. And when we talk about the SNMP monitoring, even if we talk about the Zabbix, let me bring now a little bit of the Zabbix on the screen. There we go. We have, if we talk about the templates, SNMP, there's actually a lot of them, right? We can see there's something from Brocade, Aruba, Cisco, D-Link, Dell, generic, HP, and there are 4 pages, and in total 151 different templates for all sort of different SNMP devices. And obviously, like not all of them, you can find a lot in the internet, and there's also integration page in the Zabbix where you can find a lot of community made templates for network devices. But the thing is that whenever we talk about the basic data, like stuff about interfaces, incoming traffic, outgoing traffic, that stuff is going to work exactly the same over all sort of um, different vendors and different devices. That's why in the Zabbix we also have a template generic by SNMP, which by default, probably this one will be better. Network generic device by SNMP, which has 12 items and also discovery rules that are discovering, as example, network interfaces. And for each discovered interface, they're going to create an item to monitor incoming octets, sent inbound packets, interface type, operational status, discarded packets with errors, and speed. And this is going to be applicable for any device, may it be MikroTik, may it be Cisco, again, Ubiquiti, where's anything else, because they are sharing the same path and the same MIB that is shared across all of the devices. But for each of the vendor, there usually also is something specific. And that specific part is something that we cannot apply to all of the devices. And that's why sometimes when we have some um, if we have some requests from the management to set up the monitoring of Cisco, some specific device model whatsoever, and we don't know how to create a template, so we search for something in the internet and we find something which supposedly matches what we are looking for, and then we import the template in a Zabbix and we see that some items work. And those that are working are probably those that are common between all sort of different vendors, and some items are not supported because those that are not supported are most likely made to some specific vendor, some specific device, and might be even also same device but just different versions, which also sometimes happens because like vendors make also some changes to SNMP libraries, and some things might work different in between of the versions.